Hello students. Let's do another example from section 3.4 in your text. We're going to again sketch the graph of a polynomial function. What we have in this case is f of x equals x to the fourth minus 196x squared. So what we should do first is see if we can write this polynomial in factored form. So what I can do is I can factor out x squared. If I factor out x squared, I end up with x squared times x squared minus 196. Now, you should recognize 196 as being a perfect square. 196 is 14 squared. So what we actually have in the parentheses here, this is a binomial and it's a difference of squares. So I have x squared times x minus 14 times x plus 14. So, notice that the graph is going to pass through the origin. Okay, one of our x-intercepts is 0, so that's also a y-intercept. So, one x-intercept is the order pair 0, 0. Now, notice that at x is equal to 0, this is x squared, so that factor is raised to an even power. So the multiplicity is even, so at what we expect to happen on our graph is for us to have a reflection or a bounce, okay? So you can write that. So at the origin, we're going to have a reflection. And we have two more x-intercepts, 14 and negative 14. Okay, I'll write them together. Plus or minus 14. 0. Now notice that what's going to happen at those x-intercepts is the graph is going to pass through. Okay. Now, what else do we need to talk about? End behavior. What is the end behavior going to be? Well, look at the degree, which is 4, and the leading coefficient, which is positive. So that we have a positive coefficient and an even power here, so the end behavior is going to be up, up. So all of these ideas taken together should give us a nice graph. So what we're going to have to do is on our grid, we're going to draw our XY coordinate system. So 0, 0, the origin, that's an intercept. And we have x is equal to plus or minus 14. I think we have enough tick marks. Let's see. So 14 would take me out here. And it's cutting it a bit close. You don't have to count each tick mark as one. I can use a different scale for this problem. So along the x-axis, if I want to, I could let each tick mark count as 2. That way I only have to go to the right or to the left 7. That may work better for this problem. Okay, so I'm calling that ordered pair 14, 0, and then we go to the left 7, 1, 2, 3, 4, 5, 6, 7. Okay, so again we have our 3 x-intercepts. We know that we're going to get a reflection at the origin. The graph has to pass through at both of these x-intercepts, and on top of all of that, we have this end behavior. So we should be able to get a rough sketch right now. It won't be perfect, but as long as we address all of these things, it should be good enough for our purposes. Okay, so notice that we have the correct end behavior. We get a reflection at the origin, and we get the correct behavior at these x-intercepts. So let's compare with what we would get on the computer. I typed this in already into Desmos. Okay, so this is the picture the computer is giving us. It's the same idea, okay? So do some more of these problems, get some practice. I promise you'll have a question like this on the test and probably the final exam as well. Contact me if you have any questions.